All right, we're still cruising in the exponential section, and we're going to focus on compound interest formula tonight. Here's our warm-up. Using the formula PERT to answer the following questions. Jackie's parents invest money at an interest rate of 6%, compounded continuously to save money for Jackie's college education. How much money did the parents invest when Jackie started first grade to accumulate $20,000 after 12 years? So again, we've talked about this the previous night. We've got to identify all the players. So 6%, my rate then is actually 0.06. Move that decimal 2 places. It says 12 years, so my time is clearly going to be 12. The question is, how much did they invest? So how much is the principal amount? I shouldn't know that. When I have a final accumulation of $20,000. So again, that's just kind of simple reading. Identify the players, and now we'll plug it in the formula. So I'm going to go 20,000 equals my P, don't know it. E is the number E on the calculator, Euler's number. And I'm going to raise that to the 0.06 times 12. Okay, so let's practice solving this equation out. So I've got my $20,000 on this side. All of this junk here, E raised to this. E is a number. 0.06 is a number. 12 is a number. Carefully, very carefully type that in. So I get 2.05443, etc. times P. And I'm simply going to divide that number I get out on my calculator, using the store button there, and I'm going to get a principal of $9,735.05. All right, so a nice little warm-up here. Okay, so we reviewed compounded continuously yesterday, and you just saw another example of it. The next formula that you have to know that they are not going to tell you is the compound interest formula. So this has to be converted to your memory. So again, you probably had it memorized at one point because we've had many tests on it. We just haven't seen it in a while. So I just want to again identify the players here. The A value is the final amount. Get it in your notebook. Your P value is your initial amount. Your R is your interest rate. N is the number of compounding periods. And T, of course, stands for time. And we reviewed this yesterday. We'll hit it one more time. Annually would mean 1. Semi-annually is twice. Quarters 4. Monthly 12. All right. Question number 1. Robert invests $800 into account at a 1.8 interest compounded annually. Whew. So I'm going to stop there. You've got to know what formula are they talking about. Are they talking about PERT or the one we just mentioned here? Well, compounded continuously is PERT. Therefore, they're giving you a compounded time frame, so we know this is the compound interest formula. So I'm going to start by writing it down. A equals P times 1 plus R over N raised to the NT. Now, the reason I think this formula is so easy to remember is it's just like exponential growth. So let me revisit exponential growth. That's P times 1 plus R to the T. The only thing I'm adding in here is dividing by N and multiplying by N. So it's really a formula you're comfortable with already. We just have to remember to put those two N's in there. All right, so we invest $800. So what are they telling me is the $800? Well, that's my initial investment. So again, I'm going to identify my players. My P is 800, 1.8%. My rate is 0.018. Compounded annually, so the number of compounds, annual meaning 1. He makes no deposits or withdrawal for 3 years, so I know my time is 3. Which formula will be used to find the account after 3 years? Well, let's plug it in. Don't even look at the choices. Let's plug it in. So I know I have 800 times 1 plus my rate is 0.018 divided by 1 raised to the 1 times 3. So as I look at those mathematical choices and I add up inside here, 0.08 divided by 1 is itself, plus 1, I would get 1.018 to the third. I'm thinking it matches closest or exactly with choice 4. Number 2, Dwayne plans to make a one-time investment and wants to reach $10,000 in 36 months for Kira's wedding. He finds an investment with 3.5% compounded monthly. So right here is where that formula is jumping out at me. They didn't say continuously. They gave me a time frame of compounding, so I know I have to use that formula. So without looking back in your notes, remember, it looks like the growth formula. The principal amount times 1 plus the rate, and the t, now just say divide by n and multiply by n. And it's the same formula, basically. All right, so let's identify the players. Do I know the amount, the p, the r, and the n? All right, I see a 3.5%, so I know my rate is going to be 0.035. I want to reach $10,000, so is that my initial or my final amount? Hopefully you're saying that is your final amount, because the question is how much should you invest, so what is the initial amount? And n is going to be the number of compounds, and it says compounded monthly, so I know I'm going to go with a 12 there. And son of a gun, I forgot my time, so let's get our time in there. Our time, now here's the catch on this one. It does say 36 months. But remember, in this formula, t is measured in years. So I'm not going to use 36. I'm actually going to use 3 for years. And I'm going to kind of underline that so you remind yourself of that. It's in years. So now that we've got the big dogs listed, let's go ahead and stick them in the formula. I've got 10,000 equals my p, what I'm looking for, 1 plus 0.035 divided by 12, raised to the 12 times 3. 12 times 3. And again, the more you clean up, the easier your math will be. So I'm just going to carefully type this in, this 1 plus 0.035 over 12. I get some hideous decimal, of course. I've got 1.0029. 1666. Now do not round. Write out the long annoying decimal or store it. You cannot round unless it is a final answer. Raised to the 36 there, 12 times 3. Now again, I'm going to keep cleaning up because that makes life easy. 10,000 equals my p. I can type all that jazz in my calculator. I get 1.110540876, and then I'll simply divide that number over, and I'm going to get a p-value of $9,004.62. So in order for me to reach $10,000, I would have initially had to invest this $9,000 at a 3.5% interest rate. And again, that was only for 3 years, so it shouldn't be surprising that this didn't increase by too much because you've only invested your money for 3 years. All right, number 4, a homeowner invests $15,000 at an annual interest rate of 4%. What will the value of this investment be 6 years if the investment is compounded quarterly? So again, they give you a compounded quarterly, so you should know the formula. At this point, pause it, list out your players, and then turn it back on to see if we have the same players, and then we'll kind of plug and go from there. So pause it and get some practice here. All right, see if you agree with mine. I said 15,000 is my P, rate is 0.04, compounded quarterly, think of 4 quarters in a dollar, 4 quarters in a school year, T 6 years. So if you agree with that, go ahead and plug them in the formula, and then I think it's a pretty basic plug and chug one because the A is already by itself. So I've just got mine plugged in, and like I said, the A is by itself, so just type it in the calculator exactly how you see it. And hopefully we agree with the same value there. All right, now let's make the math a little more interesting here. Linda invests $6,000 into account. After 5 years, her investment reached $7,200. If the interest was compounded annually, determine the rate to the nearest 1/10%. So this is going to get ugly mathematically, but again, pause it, get your players identified, and we'll go from there. So again, when I say this formula in my head, I want you to see what I'm thinking. I'm thinking, okay, it's growth, P times 1 plus R raised to the T, and then I say, okay, it's compounded, so divide by N and multiply by N. And again, that's how I remember the formula for myself. All right, so identify your players, pause it, see if we agree. And so I've got my players listed. I've got them plugged in my formula. Hoping you're agreeing with that. And I'm going to work on solving this puppy. So I'm going to remind you that this 5 is attached to this exponent. So those can't get broken up, or that base. So the first thing I'm going to do is divide by 6,000. So I've got 72 over 60, which I believe is 1.2, equals that 1 plus r to the 5th. Okay, now the only way to get rid of a power of 5 is to take the, you've probably guessed it, 5th root of both sides. Whatever I do to one side, let's make sure we do to the other. So this is a ugly answer. I get 1.03713729, I think, equals 1 plus r. Remember, no intermediate rounding. Subtract over that 1, and I get this lovely decimal. So I would say my rate is actually 3.7 to the nearest 10th percent. All right, Jack and Jill went up the hill, are twins. And they each received $2,000 for their 16th birthday. They decide to separately invest their money. Jack is going to invest his money at 3.7% compounded quarterly, and Jill's going to invest 3.6% compounded monthly. So they have different percentage rates, and they're getting compounded differently. Write a function of Jack's option and Jill's option and calculate the the value of each amount after 2 years. So let's do it. Let's start with Jack. Okay, so Jack is going to invest at 3.7% compounded quarterly. So I'm going to start with my formula. A equals P, 1 plus R to the T, divided by N and times N for compounding. So I'm going to say his amount is $2,000 times 1 plus the rate of 0.037, compounded quarterly, so divided by 4. And 4t. All right, let's talk Jill. Jill is going to, let's see, she's going to invest her $2,000. 1 plus, now her rate is 3.6, slightly less, but she's going to compound monthly. So is there any effect on this compounding raised to the 12t? So that's probably where they're hinting at here. Is there any effect on this? So we wrote their two formulas after t years, so we use t as the year value. And now it says determine who will have more money by the time they graduate high school in 2 years to the nearest cent. So basically you're going to replace both of their years with 2. So 2,000, 0.037 over 4, raised to, or hopefully you're okay if I call that 8, if I plug in my 2 for my years. And again, the A is by itself, so this is easy math. You're just typing it in exactly how you see it on your screen. And I've got 2152.88. Hopefully you can agree with that. And then we'll attack Jill's here. So she's got 2,001 plus 0.036 over 12. So after 2 years, that's going to be raised to the 24th. And again, just kind of plug and chug. We'll see who makes more money. She's got 2149.08. So she had a lesser percentage but compounded more. He had a slightly larger percentage but compounded less. Algebraically determine to the nearest tenth of a year how long it would take for the initial investment to triple. And we're specifically talking about Jill's. So if Jill's initial investment triples, well, right now she invested $2,000. If that triples, she's going to multiply her amount by 3. So we want to know when her amount will reach $6,000. So I'm going to say, okay, 6,000 equals Jill's equation, which was 2,000 times that 1 plus 0.036 over 12 raised to the 12t. And I'm not using the t equals 2 anymore because the question is, to the nearest tenth of a year, figure out that year, what that's going to be. So, hopefully pretty straightforward by now. These guys are attached together. I'm going to clean up inside there. So let's see, that's 6,000 equals 2,000. Throw that in my calculator. I get 1.003 raised to the 12t. Again, this is attached, so I'm going to get rid of this 2,000. Bam. I'm going to kill my zeros so I don't have to worry about those. So I've got 3 equals 1.003 raised to the 12t. exponential, the only way to solve this is to take the ln, or log, of both sides. So when I take the log of this side, it's going to take that exponent and bring it down in front, times the ln of 1.003. Carefully divide each of these out. 1.003, bam. The ln of 1.003. So I'm going to get a number. I'm going to call that A equals 12t. Divide out my 12. And let's see, hopefully you get a t value of 30.6 years. So she won't triple her amount until she leaves it in for 30.6 years. Well, just as you suspected, we're going to get some great practice with this tomorrow. So we look forward to seeing you. Have a great night.